There has never been a greater threat facing the manufacturing industry than the environmental impacts associated with their activities. The need for doing more with less is clearly apparent in every aspect of our life, and will become even more so as the rapidly rising global population significantly increased demand on manufacturing. Increased consumerism, the impacts of climate change, and the depletion of natural resources will mean that the challenges facing future generations will be even greater. The Center for Smart was established in 2004 to provide a focus for research in sustainable manufacturing and reuse recycling technologies. This includes projects on design, materials, energy, water, and recycling as encapsulated in the Smart Temple.
Design is the most influential activity in determining the environmental impact of any product. But few products that we use today have been designed with environmental considerations in mind. The application of eco-design for different products will inevitably focus on different environmental impacts. These may include, for example, amount of material, chemical use, energy and water consumption, and recyclability. By now, you may ask why I'm not applying eco-design for every product we make, and there are two main reasons for this. One, there's a skill shortage in this technique, particularly in small companies, and two, designers already have a huge number of considerations. Developing appropriate tools to support future designers forms the basis of our research in eco-design.
The need to find new sustainable materials and technologies has never been greater. Our ability to produce alternative materials from renewable, non-polluting resources is clearly essential for a sustainable future. For example, the remaining reserves of fossil fuels, from which the majority of today's plastics are derived, have become increasingly harder and more damaging to the environment to extract. It is this promise of sustainability, the fact that materials are renewable and biodegradable, that makes biopolymers so attractive as a packaging medium. However, concerns exist as to the real environmental benefits, particularly in the raw materials used for their production and the separation and recovery from existing waste materials. Within the Centre for Smart, we're using the latest life cycle assessment methodologies and tools to understand how the environmental impact of biopolymers compares against their conventional counterpart, and so as to identify where the best and greatest environmental gains can be achieved. As one of the deliverables from a wider study, a decision support tool has been developed to provide direction for companies considering the use of bio-derived polymers, and to assist in their selection and application during the pack design process. Another project will investigate alternative waste recovery technologies to improve the conservation of the materials post-use. These are just two of the many projects on biopolymers and sustainable manufacturing taking place within the Centre for Smart.
Energy is an inextricable part of life in the 21st century. Its availability and utilization will become increasingly important over the concerns of climate change and the escalation in worldwide population. Much of that demand is currently met by carbon-based sources such as coal, oil and gas, which accounts for 2/3 of the world's greenhouse gas emissions. As a significant contributor to climate change, you would think that we would try and reduce our demand over the coming years, yet energy demand is estimated to be 45% higher in 2030 than current levels. There are two ways of addressing this issue. One is turning to green sources of power generation, the other is the efficient management of energy demand. In the foreseeable future, the minimization and optimization of energy consumption still provides the greatest opportunity for reduction of greenhouse gases. Energy-efficient manufacturing not only reduces the overall environmental impacts, but could also provide substantial cost savings and provide competitive advantages for these companies. Here at SMART, we have developed a novel modeling framework to predict the amount of energy consumed by a single product during its manufacture, as well as establish a breakdown of the energy consumed within a factory. We believe that this approach provides greater transparency on energy efficiencies within the manufacturing system, enabling manufacturers to improve the energy utilization within their operations, as well as improve product design to minimize energy consumption over a product's life cycle.
Water is one of the most important Earth's natural resources, essential for life and omnipresent in our daily lives. Manufacturing in particular uses substantial amounts of water. By 2025, this demand for water in manufacturing is expected to double. While water is one of the most abundant resources on Earth, it is not always available when, where, and of the quality needed. Here, at the Center for SMART, we are developing a framework for sustainable consumption of water in manufacturing. Specifically, this involves two key approaches. First, eliminating or reducing freshwater consumption through alternative technologies. And second, reusing or recycling wastewater for activities both inside and outside the company.
Human society generates a huge amount of waste, and the need to recycle and reuse products is well documented, yet often poorly implemented. For example, in the footwear industry, it is estimated that some 20 billion pairs of shoes are produced worldwide. However, less than 5% of these shoes are currently being reused or recycled. For many products, there are often problems with identifying the optimal end-of-life management process, where establishing a recycling and reuse process often means balancing the economic needs versus the environmental impact. To address these issues, there is a strong need to develop new technologies and processes, as well as design tools and business models that support product recycling and reuse. At the Centre for SMART, we are involved in developing recycling and reuse technologies and end-of-life decision-making frameworks for various product sectors, including automotive, electrical and electronic, and we are currently working with a number of key stakeholders in the footwear industry to help minimise the amount of post-consumer waste. As part of this present industrial collaboration, we have developed a number of bespoke recycling technologies for economically sustainable reclaim of footwear materials, and developed a design for recycling approach that seeks to improve the quality of reclaimed materials, as well as reducing the recycling processing costs. The reclaimed materials can be used for a number of useful applications, such as surfacing, insulation, and even virgin materials to make new products. These recycled materials can generate revenue as well as providing environmental gains, making footwear recycling a viable alternative to that of landfill.
At present, the needs of the manufacturing industries are wide-ranging and demand a holistic approach to develop practical, sustainable solutions. Therefore, at the Centre for SMART, we will continue to research the entire life cycle of not only the products, but also the processes and production systems that are used to manufacture them. Thank you for your interest and attention. We are always happy to hear from any individuals or organizations that share our vision.